Alright, in this video what we're going to do is we're going to look at solving exponential equations that have non-equal bases. In the previous video we looked at how to solve exponential equations using equal bases. This time there's no way for us to make those bases equal each other. So we can use one of three methods. Each of these methods will get you the correct answer, and honestly it does not matter which method you use. It's actually a matter of preference. So let's just take a look at an example. In this example, we have 2 to the x is equal to 30. Now, it's very clear that we cannot change 30 to a number that has a base of 2. For example, if we just even take a look at 2 to the 4th, we get 16, and 2 to the 5th is equal to 32. And so there is actually no whole number that we can set equal to with a base of 2 that will yield the 30. So in this case, what we're going to have to do is we're going to have to resort to other methods. And the first and second method are very similar to each other. We're just going to be using different types of logs to get the correct answer. But at any rate, if you look at this, it says take the log of both sides. And we're just simply going to apply the golden rule of algebra, which states that whatever you do to one side of the equation, if you do it to the other side of the equation, you're going to get an equivalent answer. So here I've taken the log of both sides. And keep in mind this is base 10, so we can put it into our calculators. Next, we're going to apply the properties of logarithms to this. And we're going to take that x, which is the exponent, and we're going to cut and paste it out here in the front, and that is one of the properties of exponents that logarithms that we've talked about. Next, since we're trying to solve for x, we're going to isolate it by dividing both sides by the log of 2. Now here in a second what we're going to do is we're going to go to our calculator, but I'd like to just show you that all three of these answers gives us the same, or all three of these methods gives us the same answer. In the second method I just simply took the natural log of both sides, and that was done the exact same way. Actually, we're just using the ln instead of the common logarithm, and the final answer is ln 30 divided by ln 2. Now this leads us to a very interesting situation in this third example. It says convert to logarithmic form. Now we know that a logarithm is an exponent, and so when I go to this exponential equation, I can convert it to logarithmic form. Since the logarithm is the exponent x is equal to the log base 2 of 30, and we've talked about how to convert that in previous lessons. But we've never really looked at what this is equivalent to, or how we can put it into our calculator. Actually, we've just kind of said we couldn't put it into our calculator and left it at that. But keep in mind that all three of these answers are equal. So log base 2 of 30 is equal to the log of 30 divided by the log of 2. Which leads us to what's called the change of base formula. The change of base formula states that if you have a logarithm with a base of b, you can rewrite it as a common logarithm just simply by converting it to a division problem. We take the log of a divided by the log of b. b is obviously the base, and you can kind of remember that as that little b is kind of in the basement. It's sub b, and so that in this particular template the log of b is in the basement or the downstairs of this fraction, and so that gives us what we call the change of base formula. Now let's take a look and make sure that these answers are equivalent. As we put these into our calculator now, we see the log of 30 divided by the log of 2 gives us 4.9. Keep in mind that that 30 raised, we looked at that 2 to the x. We know it's going to be between 4 and 5, closer to 5, and so that answer makes perfect sense. And again, we get the same exact answer by using the natural log. So those two particular methods are almost identical. You're just using a different keystroke. What I'd like to do now again is to just practice a few change of base problems with you. So if I had the log base 5 of 7 and I wanted to use my calculator to find this answer, then according to the change of base formula, this is equal to the log of 7 divided by the log of 5. We could also again, this is interchangeable with a natural log. We could actually use natural log and get the same exact answer. And this would give us what we're looking for. So once again, let's just do one more. The log base 3 of 8. Okay, this is going to give us the log of 8 divided by the log of 3. Again, according to this rule, you're going to follow this format, and so it's going to be the log of the big number, that's the numerator, over the log of 3, which is in the denominator of this fraction. So that concludes this video, this tutorial, and we'll look at some problems in the next video.